let's talk or discuss Singleton. So Singleton is a creational design pattern, okay, that restricts a class to have multiple instances, and it only allows to have one instance throughout the applications and provides a global access point. So there are like some, if you read any website or any blog, books, some, most of them said, okay, this is a creational design pattern, this have a single access point. Okay, you can use it in cases like database connection polls and logging implementations, etc. Okay, let's put that all BS away and let's really see what's going on in there and what other kinds of singletons are there, what other kinds of implementations people came up with, and what people expect you to know when they ask you about singleton pattern. All right, so we all know, and let's not, okay, there is, okay, why design patterns, let's ask the question. So there is a whole theory of why design patterns exist, and in fact you can live without design patterns also. I mean, functional programming languages don't have design patterns. Okay, it's the OOP, it's the language like Java. Sometimes that's a pain in the A, but uh, okay, let's not get into the whole philosophy of why design patterns and why not. Or so most people, so people who agree with design patterns, see, what happens is design patterns make up for the inefficiencies of the language. Those who hate design patterns and those who do functional programming languages simply say your language is stupid, your programming language is stupid, that's why design patterns exist and they are like a plague, you should avoid them. And those who learn design patterns apply to every single fucking thing, like even if there is no need, they try to invent a problem so that they could apply singleton pattern. So that's it really depends on every person. It's an individual thing, different people perceive it differently. So, but I would say I would avoid design patterns, but there will be a need. So only when it is really needed, I will use design patterns. I am on that side of the court. But when do we actually need it? Do we really need it? Okay, how much complication can we tolerate before we look for a design pattern? So these are all questions you must ask yourself when you are trying to implement a design pattern in your piece of code or in your application logic. But let's discuss few use cases anyway that looks uh, you know that looks reasonable to use instead of applying this to everything. So let's so what is a singleton design pattern? We already discussed on global one instance throughout uh, global access point. Okay, that's it. Okay, we can go into deeper implementations of how logging works, how database pool works. I do have a video planned for logging implementation with factory and with singleton pattern combined, but okay, this it's not for this video. It's just okay. Oh, let's go to the basics. Singleton pattern. There are several ways to implement. You could implement it a lot of ways, but let's go through the basic one, which is called eager initialization. Okay, eager initialization means you are already creating the object at the time of at the start of your application and you are preventing further creation. That's the simplest way to implement a singleton pattern. Okay, you are initializing for this to work, have to know you you have to know what are all the values you're gonna need that is shared across your application. So let's say this is some stupid implementation anyway. No, say this is not okay. Enums solve this problem already, and one global variable or one class or one util class with a static final variable will solve this problem anyway. But this is a way of implementing singleton pattern. And remember, and singleton patterns came or design patterns came at the initial stages of Java around 1.4, 1.5, even before Java 8. So that at that time there are programming language, the Java language had quite a lot of deficiencies or bad or a lot of holes. So that's why people came up with these patterns. So just because they're design patterns doesn't mean they're all good and you have to use them all the time. So this is just to learn how it works. And okay, you're learning design patterns only because someone is going to ask you few questions about them. Okay, actually using it in your real world application development is completely different. Although it is good to know there are several kinds of things, several kinds of design patterns and all that crap, but you don't need this. You don't need to see learn this piece of implementation to do real world application development because it's nothing really. It's bullshit. But let's see how it works. So, so, so I'm thinking of another example. Say, let's say you do have a database pool you want to initialize. So you don't want to use the Spring JPA library, or you don't want to use the ORM at all. You just want to write your own implementation where you just pass up the query, you parse the query, you execute the query using JDBC library and all that. Uh, there are multiple ways actually, but let's not go deep into that. We are just here to learn what is Singleton, that's all. Okay, I'm getting off the track. Okay, this is eager Singleton. Okay, uh, let's, it doesn't matter because so it is obvious, right? It is obvious. We don't even need to test this one. All right. Actually, we can even make this final so that the variable doesn't get modified at all. Okay, sorry, the instance doesn't get modified at all. So there is nothing much to talk about this in Eagers implementation. At the start of your application, you're creating a object and you're preventing. See the private constructor here. You cannot use new keyword. You cannot initialize, and we gave the single global access point. So not much to discuss here. Okay. Okay. Let's say so all these lessons come with some imaginary crap, right? So let's say if your instance is costly and you don't need to use it unless you really need it, okay, that's when you go to this kind of implementation where you will only create it when you're using it for the first time. So all these imaginary problems, right? So what if the instance is costly? What if it takes too much memory? Or what if it, what if the compute is costly for it? Then why are we keeping it in memory? Then we shouldn't we use lazy initialization like this one? That's an imaginary crap problem. Like most 99.99% applications doesn't need this crap. Okay. So as if the other code is not bad, or as if the other dependencies, other legacy libraries are not bad, you're only focusing on this single implementation. That's bullshit. This is called over engineering or over complicating your problem that doesn't exist. Anyway, people would like you to know how lazy initialization works. Okay, if you look at this implementation, okay, we have the instance obviously, and we are providing a global access point. Okay, and this time we are going with a dynamic value. Let's say because you are initializing it lazily, you don't know the value is previously. Okay, you don't know the value previously, so you're assigning at the runtime. Okay, 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 there is a flaw here. Generally that's what people ask you, or interviewers ask you. That's what we are doing. We are learning this crap just because some people have some stupid questions about this one. Okay, there is not much to explain here also. At the given point of time when you are accessing it, if you check for null, you initialize it if it is null, otherwise just return it. So but this fails in a multi-threaded context. So okay, let's do it anyway. Let's do some simple testing for multi-threading. So let's use it in a multi-threaded environment and see. So let's test it simply first. Okay, naive singleton delete. Okay, so you are getting that instance first. Okay, that means in the first statement the instance value will be null, and the naive singleton will be initialized with the value of delete. Okay, the second time though, this value will be ignored because this condition, it's not null and this won't be executed. And second time also you must see the value delete even though you gave the outcome. Yeah. Okay, it works. Now if you swap this out, what must it print? The outcome obviously. Okay, let's test this in a multi-threaded environment. Static class thread a runnable. Okay, var s1 is equal to, okay, let's copy this over here. See, okay, let's remove this here. Thread a is equal to, sorry, let's go over here. So we have two threads initialized. Okay, let's start b dot start. Okay, let's run this over multiple times. All right, you are not gonna get two different. Okay, the expectation is this will fail and two singleton instances will be there, but this may not be the case always. This will be the case sometimes, so we have to run it multiple times to find out the result. See, now you got two. Before we ran, we got two totems. Now we got one totem on the lead. So that means this is misbehaving. Alright. So we need a thread safe singleton implementation, which means which will prevent uh, creating a singleton object by two threads at a time. Okay, this is where the real one comes in, double checked locking. DCL means double checked. Okay, double checked locking. Okay. Uh, okay, this is a bit tricky one, and most interviewers ask this kind of condition to. Okay, this will also test your understanding of threads, the word synchronized, the word volatile, etc. So uh, I do have this screenshot of how volatile works. Uh, Basically, why volatile is because creating an object is not atomic. There are there are multiple stages. Allocate memory, allocate, okay, sorry, initialize fields, etc. Then return, then assign the memory address to object or something to the variable. Okay, it's not exactly like this, but along these lines. This is the kind of step that will happen. So if you are using volatile, okay, one second, let me get this. Okay, let me show you the, actually I have it here. Okay, let's, I have this. I do have a screenshot, but that's in a personal chat, so I can't really open it right now. So, okay, this is what happens with volatile. Just remember that. I will show you later exactly how volatile works. I had one screenshot to explain it. So, okay, just remember that volatile is necessary in a multi-threaded context environment because it it prevents returning a partially initialized object because there are multiple steps in object creation. So allocate memory, right after allocate memory, the object value will be null. That means this will be returned. Okay, volatile and the rest of the steps doesn't happen and it will only return a partially initialized object, introducing subtle memory bugs. Okay, we will go into that deep very later. But let's go through this implementation. Okay, if instance is null. Okay, if instance is not equal to null, this if condition won't go through. This instance will be written. This instance will return, which is already an initialized singleton object. Okay, what does synchronize do? Means actually there is another way to implement this. Okay, instead you will put like this. Okay, like this one. Okay, this also works. This one will also work because synchronized. What does it do? It will lock. So thread A is running. It entered this method. So we are putting a lock. If thread B is trying to access this method at the same time, since it's locked, it has to wait for it to unlock. Okay, you see it, you see what I'm trying to say. Okay, but this has a flaw because uh, every time you try to use this get instance, you're locking even though when it is not necessary. You have to lock this only when you're trying to create the singleton object. Okay, so that's why we are checking for null here first, otherwise we are returning. And if it is null, we mean to create the object. So that's when we have to lock. That's where the synchronized block is inside here. And why the second instance null means, so until this point, so two classes can arrive or two threads can arrive to this line below at the same point. Okay, if instance is null, uh, okay, why the second null check means, let me explain clearly. Thread A went inside, it started initializing the singleton object, singleton instance. Okay, pretend this didn't exist. Okay, okay, thread B went inside, checked for null, it didn't, it is not null, it isn't null, return the instance. Okay, which means there could be partially initialized scenarios like we discussed with the volatile keyword. Okay, second null check is to like really make sure if it is null. So let's say both threads enter this context at the same time. Only if it is null you are initializing second time. So let's imagine two threads like this. Both are trying to do the same operation. If there is no null check, both will be initialized again. Okay, that's why this double check locking needs to be there. Okay, I hope you understood. But let's replace naive singleton with DCL singleton. Okay, this means thread A is starting first, which means the value should always be deleted no matter how many times you run. It will always be Dilip. So it will always be Dilip or Tautam because these two threads run parallelly, not one by one. Okay, both value will be same. Okay, now if I meant to write a dot join b, okay, if I write like this, it will always be Dilip. That means the other threads are waiting for it to complete. Okay, now the point is the both values should have both both should have same value. Now somewhere totem should pop right there, right like that, like that. Yeah. Now if I write like this, doesn't matter because both are found of paralleling. Or if I write like this, wait until be finished. Now it will always be totem, no matter how many times we run. No matter how many times we run. So okay, let's do this anyway. I didn't do this. Let's remove this second null check. Let's see if this any odd behavior pops up. Okay, to our point of separately. See, we leave the automate. The first only we got because we are running, 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 running. See, you got it there, right? So this is actually breaking the singleton condition. So the singleton behavior, I mean to say. So we have to check for it. Okay, we have to check for the second one. Now this behavior won't be there. Now this behavior won't be there because we prevented it from happening, like we discussed. So this is double check locking. You try to go through the code once. It is really helpful to experiment with this kind of stuff. See, just like we expose this problem of not having a second uncheck. Okay, now there is another implementation called build pew implementation, where where you will solve this naive singleton by lazy. So where you solve eager initialization problem by hiding it inside a class, static class. So the thing with the classes is it will not be initialized or instantiated until it is called. So instead of eager singleton initializing directly, you will initialize only when this get instance method is called, which is the global access point anyway. Now this came at a time of early Java days. You don't really need this kind of implementation, but it is good to know. And now there is one by Joshua Block where will be a single class singleton implementation, and of course it is a singleton because enums are initialized once and its value is permanent. You can't change it, so it can be used everywhere in your application. It's like the most obvious point, right? So you don't really need any experimenting with it. Let's so this is an important one, double check locking. So I wish I had explained volatile and synchronized a bit more clearly, but this is good enough for a singleton video, I think. And now I did try to implement this logger class in a singleton style, but ended up learning that it also needs some factory implementation because I wanted to give the package level and the class name as well so at the time of initialization. So I will do another video where explaining factory pattern and logging implementation. I and I will also try to use the singleton in a real world. Okay, let's discuss the real world use case for singleton. Uh, let's say you have a order processing service and each order has a unique ID, right? So you want to log, right? So you want to whatever the logs are there in the processing flow. So it would be helpful if you prefix that log with your order ID, so it is easier to debug. So at the time, so you can have a thread local variable or a singleton class where you set the order ID at the time of flow initialization or at the time of starting your flow, so that the thread local variable will be accessed everywhere in your thread, thus prefixing your log with the order ID. So I wish I could show you, like, but I am planning to write a order service implementation just to show various design patterns or various logging, the other kind of stuff. So I do like to explain with real code, so I'm not gonna write some fake bullshit explanations like bird extends tree or car extends vehicle. All that crap is bullshit. So you don't. So what? So my I really hate this kind of explanations. So when trying to explain inheritance, like let's say there is a vehicle and there is a car, and there is a truck. Like what kind of explanation is it? Does it really explain the concepts? Like how do you use it in real world software anyway? So I hate those kind of explanations. That's why I like to talk through it. Not yeah, okay, forget anyway. We'll explain the synchronized and volatile keywords in another video. So I hope we are done now. Thank you.